Good evening, everyone, and welcome to another installment of Whiteboard Wednesday. We're live on the YouTubes, the interwebs, all that good stuff that goes along with it. So I'll give everybody a couple of minutes to get in and get started, and all the good stuff that goes along with that. So as I mentioned, let me go ahead and open up another YouTube studio so that I have my comments, or my posts I should say, available to me, and we can start taking a look at this. So the goal with tonight's Whiteboard Wednesday is to focus on the design piece of exam preparation. So it's something that I get questions on a regular basis. Instead of having to look all the way over there, I'm going to bring it closer. So a common thing for folks is when they're starting to get into networking and understanding how networks are put together, how they're glued together. So I'm going to talk a little bit about how the different topologies and the different network designs that are out there come together and things like that, because to me that's rather important for you to know. It's because if you start talking to somebody else that's in networking or IT and you start talking about different layers of the OSI model, or you're talking layer 2 or layer 3 or layer 1 or whatever the case might be, a consistent thing that is needed to be understood is to be on the same page terminology wise with whoever you're talking to. So we'll spend some time digging into how design comes into play. You know, what are the different types of design? Why would you choose one design over another depending on the part of the network you're in? Is one design good enough for everything? And the answer to that question is no. One design does not fit all. So we'll talk a little bit about how that comes into play and stuff like that. So I am live, so if you guys have any questions about any questions you want me to answer live in the chat, go ahead and drop it in the chat, and I'll be happy to answer those questions, and we'll go from there. I'll pull up, I've got Chrome ready to go so that we can start plugging in the Cisco validated design type stuff, and I'll switch my my view here from the camera, and I'll do a split screen and all that good stuff that goes along with that. So I see a few of you in the concurrent viewer, so for those of you that are watching live and all that good stuff, thanks for stopping in. So I've given everybody a couple of minutes to get in, so we'll go ahead and get started. I'm actually going to go ahead and I think it's, there we go, there's the scene. Too many scenes to keep track of. All right, so one of the things that I definitely like to talk about, especially when you're starting to get into your exam preparation, certification journey, that type of stuff, is you need to understand why things are built the way that they are. So so for example, if we were to take, let's look at CCNP real quick. And the reason I'm starting there is because there's an actual dedicated area specifically for design. So let's look at CCNP Enterprise. And if we come down here to some of the concentration exams, you have a few of them. So design, there's a dedicated design exam for CCNP. So let's go ahead and take a look at that and see what the details of that are. So let's go ahead and take a look. So we're going to review the exam topics and see what's going on here. Okay, so you have the addressing and routing solutions. You've got advanced networks. Then you have WAN connectivity. Then you have network services and automation. So let me talk a little bit about the details behind this, because I'll start from the top and I'll work my way down. The other thing I'm going to go ahead and open is the Cisco validated design. And if we come over here to the design zone, you're going to have a bunch of different options available to you to look through. So you have your different design guides. Now, why does this matter? Why is this important? Well, it's important because if you're just getting into networking, or let's say you've been doing networking for a few years, and you've had, like, you work for a customer, or you work for an organization. I refer to them as customers because I've always been, for the bulk of my career, I was a consultant. So to me, it's always I'm working to help somebody else's network. So when you look at it from that perspective, the organization that you work for, you're probably going to have meetings in conference rooms with vendors are going to come in, whether they're internet vendors, whether they're hardware vendors, software vendors. You're going to be buying services and solutions from other companies to help build your network. That's just the way it works. So whether that's Cisco, VMware, Microsoft, Amazon, VMware, and those are just the vendors that I've worked with. There's, I'm sure, tons of other vendors out there that are deal with security and collaboration and all the things that make your network tick. So when we take a look at this, you're probably going to be having conversations around these things, and it's going to be important when you're getting into the weeds of your job, whether you're a 1 or 2 year old network engineer, or you're more senior and seasoned and you've been doing this stuff 10, 15, 20 years. You're going to be able to have, you're going to want to be able to have the conversation with these folks. And you're not really there to be a subject matter expert, right? A lot of these vendors, they are specializations in a particular thing, right? Whatever it is that they do. Appreciate that, man. I am doing everything I can to keep up the good work. You're going to want to be able to have these conversations, and the conversations are going to, if you're the customer engineer and you're bringing in a said vendor, I don't care who they are, and they're diving into the technology, they're going to be talking about how their solution works. Sometimes it's going to be high level, what the goal is. They're going to ask you questions around your environment, that type of stuff. They're going to kind of see if what they've got going on makes sense for you. So they're going to do some discovery, figure that type of stuff. It's kind of a pre-sales kind of thing. I work in pre-sales now, so that's what I do a lot. I don't deploy, but I do a lot of design. So I will talk to customers. I was actually at a customer location today where we talked in depth about their network. Well, I never even picked up a marker to go on the whiteboard, funny enough. But it was one of those things where the longer we talked, the more and more notes I took. Yeah, I'm a big note taker. I sit and I jot things down so that I can come back to them later. So what that does, though, when you're having those conversations with these vendors, is I recommend that anybody, regardless of their experience level or their tenure in their engineering career, you spend some time going through the design guides. Because at the end of the day, you're going to want to have a general idea of what's going on. Now, I don't want to say that vendors are going to try to pull the wool over your eyes or try to, pass one over on you, take advantage of you. But, if you're going through and you're doing your due diligence as the engineer, you're not wholly relying on the vendor to do the heavy lifting for you, this is something you're going to want to do, because as you're progressing through the decision process, and you're talking about a particular solution, and they give you a proposal and they say, okay, our solution is going to do this, and this, and it's going to cost you X. Okay, so is that X going to be a CapEx, capital expenditure, or is that X going to be an OpEx, or a combination of both? What's an operational expenditure? So these are some things that you're going to have to understand and take into consideration when you're having those discussions with your vendors. So I am a proponent, always have been, always will be, of making sure that I understand or at least I try to do my best on keeping up to date with the latest trends and things like that. Is it difficult? It is. I'll be honest with you. Unless you're constantly reading up on vendor documentation, how many networking vendors are there? I can think of probably, you've got Cisco, Juniper, Aruba, HPE, Palo Alto, Checkpoint, Cisco covers firewalls as well. So just in that moment, 6 different vendors. And how many solutions does each vendor have? 4 or 5 at a minimum. So, and how deep do you want to go into each one of the solutions? Well, the cool thing about this is you don't really need to be a subject matter expert in every one of them. That's not your job. Your job, being the customer engineer, and that's what I'm focusing on right now, is you work for a company that leverages outside sources and resources to get you where you need to be organizationally. So when we talk about that, those are the things that you need to take into consideration. You know, it's like you need to focus on the areas in which you're at least semi-knowledgeable about what's going on. So that, you know, because if you do just enough homework, and I say just enough, you know, you can have a general conversation about whatever it is that this particular vendor is coming in and talking to you about. So in those particular cases, the more up to date you are, the better off you're going to be, because now you're going to be able to have a more intelligent conversation, and you'll notice that the wheels of the process are going to spin faster because they're not having to spend as much time trying to bring you up to speed and things like that. And it's already more than likely you've already done some research. That's why the vendor's there to begin with. And you've probably already talked to a salesperson and said, hey, hey Rob, we're really trying to, for example, we really want to move away from doing or leveraging just regular routers on our edge, and we want to move over to more of a SASE, SSE, SD-WAN type of design. So you have your secure access service edge, your secure service edge. So when you take in SD-WAN plus additional things like multi-factor authentication, Duo, single sign-on, cloud connectivity, so you're starting to couple multiple things together. These are going to be more advanced solutions, because if somebody was to ask me, for example, I had this conversation in depth today. We brought up the fact that you hear the edge, the perimeter of the network. Well, in my opinion, back in the day, 10, 15 years ago, the concept of the edge was a real thing, right? You would go to your job, wherever that might be, and you would, connect your laptop to your docking station, and you would be the edge of the network, right? You would be a user connected to the network and getting connectivity. Well, nowadays, where is your edge? Well, there's a lot of the workforce nowadays is very mobile. I've got my phone here. Like, I can literally do just about anything I need to on my phone. So whether that's email, I use WebEx. It's what my company happens to leverage. So at any given point in time, I could be having a chat via WebEx. A minute later, I could be writing an email from my phone. So the concept of the edge is now ubiquitous, meaning it's everywhere and anywhere and everywhere, because you never know, especially with stuff in the cloud or stuff you have remote teleworkers. I mostly work from home. There is an office that I travel to on a semi-regular basis. So when you talk about these things, understand the architecture, the design, all these things come together to try to understand the holistic solution that's coming into play. So let's talk a little bit about some of the things that you should really be paying attention to. So on the design guide, the design exam for the major things that you're going to be wanting to be familiar with. So the first thing that I always recommend is you're going to want to understand the typical architecture, right? You're going to want to understand your typical campus design. I'll go back over here because you got campus wired and wireless, then you have branch WAN and internet edge. So when we talk about this concept of, actually this is exactly what I wanted to show you guys. When you look at the core distribution access, right? That is a big thing in a lot of organizations, is having the connectivity set up a certain way. Now, is this the only way to do it? No, it's not. Could you do a collapse core? You sure could. What about your WAN edge? So does it make sense to deploy SD-WAN, or does SD-WAN make sense for you? If you're a very static environment where things aren't moving and you don't have a ton of applications and things like that, where let's say you've got less than 10 business critical applications and you don't have a lot of inter-site communication and things like that, to me, you are not a candidate for SD-WAN. Now, are you a candidate for WAN in general? You are. WAN in general, if you were to, you could deploy SD-WAN to get yourself modernized, if you will, but you might not be taking full advantage of the solution. And I would venture to say that a lot of organizations that are doing a network refresh, or they every so many years they're going to do a refresh because they have budget and it's time for life cycle of that hardware, things like that. Well, what's going to end up happening is you're going to get to a state in the network where, regardless of if you need it or not, you're going to refresh it because that's just the way IT works. So these are some of the. So I don't want to specifically like bullet point out why you would or would not want to deploy SD-WAN. That's not what the point here is. But the driver, if you're talking to a customer and you're trying to determine are they a candidate or not a candidate, that's one of those things where you have to understand the features and capabilities, the pros and the cons, and then it's your job to go through that checklist. And if the customer is giving you, let's say, there's a few reasons why they should be, but more reasons why they're not, it doesn't make sense. I was talking to a customer a few weeks ago. They've got DMVPN deployed. And it's been working great for the past 7 or 8 years. And so I was just like, okay, are you looking to modernize your internet edge, your WAN edge? And they're like, not really. I'm like, we'll do a hardware refresh every few years, but like, it's like I don't know if you're going towards SD-WAN. I said I was going to ask about it, but it's just like you're like, we don't really see the need for it. We're not adding sites on a regular basis. Our remote workers are VPN into our public cloud that we have, and then they use VDI, virtual desktop infrastructure. And I'm like, oh, okay. Well, then you're not, to me, in that particular case, SD-WAN doesn't make sense. So, are there other cases where it does? Potentially, but those are conversations you have as you're going along. Now, when it comes down to how this stuff comes into play, let me see if I can't find a picture of the 3-tier network architecture of Cisco. Well, let's take a look at some images here, just so we have a baseline here. So when we talk about connectivity and how this stuff works, there's a couple key architectures that you really need to nail down and understand. The first of which is going to be your 3-tier architecture, your core, distribution, and your access. Now, the reason why I am a big proponent on knowing architecture is so that you can understand why the network is built the way that it's built. Is there right ways and wrong ways to go about networking? There are, but from an architectural perspective, there's best practices in place for a reason. Can you modify some stuff? Yeah, you can. But for the most part, when we talk about how connectivity is done even in the modern network, what is the thing that people do the most, right? It's in a larger location, you're going to do what? You're going to do a 3-tier architecture. In a smaller location, what are you going to do? We're going to do a 2-tier architecture. So let's actually talk a little bit about how that comes into play. So I'm going to go ahead and open this one up, and I'm going to do a 2-tier because it's important to know both. So why would you do one versus the other? As if I can't just find a picture for you. So let's talk about the 3-tier. What does the 3-tier architecture give you that the 2-tier architecture does not? Well, in my opinion, the 3-tier architecture gives you modularity and it gives you scale. Well, if we look at the 2-tier architecture, doesn't this also give you modularity and scale? It does, but only to a certain extent. at least in my opinion. Now, why would Rob say, okay, for this particular location, like an HQ or a larger office building, things like that, why would a core distribution access make more sense than a two-tier architecture? And the number one thing I will always go back to is if you have a lot of floors, let's say you have a multi-story building with lots of users on every floor, a core distribution access is going to give you more flexibility and more scale in those type of scenarios than a collapse core. A collapse core is going to be where your core and your distribution are on the same device. So you're removing the core and you're plugging everything into those devices. Now, you can do this, you could theoretically do the same thing at both locations, right? You can connect all your internet connectivity and whatnot into your core, your WAN and all that type of stuff. But actually, what makes more sense is to take this a step further, where you've got your core, right? You take the core, and then the distribution and the access doesn't necessarily connect to users. It can connect to other types of the network, whether that's the WAN, whether that's the data center, whether that's internet edge. There's all kinds of different ways to plug this in, and in my opinion, the best way to start at a larger location is to use a three-tier architecture. Is that a locked-in, steadfast, there's no wiggle room type of design? No, not at all. You might get into a scenario where this doesn't make sense. But in most of the customers that I've worked with that are larger, that have, they have a large enough footprint and they're big enough and their locations are large enough, the thing that makes the most sense is to do a three-tier architecture at their bigger sites and then a two-tier architecture at their smaller sites. So you can mix and match. So that covers why those specific things come into play. Now, if you have questions on that type of stuff, or you're like, okay, is there, I have this particular scenario, you guys want to toss that in the comments, be my guest. I'm happy to answer those questions. But at the end of the day, those are the two main reasons why you would go that. Now, and I'm also referencing best practice. So would I do a two-tier architecture at a large office building? Well, if the customer was just like, well, hey, we just don't have the capital to go out and buy these bigger boxes to deploy a core, I'm like, okay, cool. No problem. We can make it work with whatever you want. And that's what I want to talk about as my other bullet point is at the end of the day, you've got best practice, right? Whatever the thing that the industry has defined as a standard way of doing things, best practice, right? The de facto standard. Well, when you talk about those type of things, you have best practice, and those are the things that are typically done the most and widely deployed, all that type of stuff. But when you think about it from an operational perspective or a cost perspective, there are scenarios that come into play where best practice doesn't always mean you do exactly what I've got drawn out here, right? So let's say, for example, it's a budgetary issue. Listen, Rob, I don't have $250,000 to spare on a couple pieces of core-based equipment. Okay, cool. So we need to resize this, and maybe a two-tier architecture makes more sense. So can you still get away with the same level of resiliency and flexibility? You probably can. And I would say that it's not going to be that much of a stretch in order to make that happen. The key thing is, at the end of the day, especially having worked for a lot of Cisco partners, is that when you take into consideration, at the end of the day, whatever the customer needs is what you need to make happen, right? So is there best practice? Yes. Well, you follow that road until it doesn't make any more sense, until the customer starts throwing curveballs at you or what have you, and you're having to adjust to make things work. Have I implemented things that people, if I was to record like a breakdown of a particular solution that I put in play, would I probably have people telling me that I was an idiot? They probably would, but at the end of the day, I don't care, because the customer came to me with a given set of scenarios, right? They had a business driver and they had funding, and my job as the engineer was to take best practice and get it as close to the solution as I possibly could. That was the goal. That was my job. So At the end of the day, I don't care what people think. At the end of the day, my job is to get the job done, get the customer where they need to be, and in a way that they're going to be able to support it. Now, in most of my career, whenever I've deployed a solution to a customer, I have had to spend a reasonable amount of time going through and helping them understand what it is that they've got deployed. Why do I do that? Well, because most of the work that I did was fixed bid project, meaning once I was done, I wiped my hands of it. I was done. I would hand over all the documentation, do a full knowledge transfer of what was going on, and that was the end of it. Now, does that always work? Sometimes, but there are other cases where it doesn't work, and so you have to go back and you have to spend more time with them. So a lot of customers that I would work with would spend, they would go out and get a time and materials bucket, a T&M bucket, meaning we put in a particular solution. The IT members that I was working with either A, didn't have the technical depth, know-how, whatever the training needed to support that solution, B, there just wasn't enough of them to do the work, or C, a combination of the two. And often that was the case. So what they would do is they would buy a block of time from us, and I would be associated with that customer on a regular basis. So my job was to, on a weekly basis, talk to the customer, see what they were doing. They would come to me with efforts or issues or projects or whatever that they would talk to management, or leadership would give them a project because a business unit over here said they needed this done by X time frame. Excuse me. Whatever the case might be. So it was my job to work with the customer on trying to move the needle forward and forward progress on these efforts. So when you talk about that in perspective to getting stuff done, that's where best practice will be applied and until the point it doesn't make any sense anymore, or you start having to peel parts of best practice away to meet the needs of whatever the customer's got. So you can leverage these architectures as a guideline to a certain extent, but once you hit a certain point in your trying to figure out what they're trying to do flow, and you're like, oh well, you know what, this doesn't make a lot of sense. We could do this, or I'll give you a great example. Typically speaking, I'll come back over here to this one here. The Cisco, what's the word I'm looking for? I'm looking at the spine leaf architecture. Okay, so we take a look at spine leaf, right? So we're going to take a look at this. It's going to say VXLAN. So let's say, for example, we take a VXLAN fabric. For some of you that are studying for your data center exams, or you're studying for your CCIEs and that type of stuff, that there's going to be SD access involved in it or what have you, and you got to deal with VXLAN. VXLAN is a completely different type of architecture that is not the same as 3-tier and 2-tier, right? It looks similar in some respects, but the key difference between your 3-tier and your 2-tier architecture compared to your spine leaf is that your spines, or your core distribution, do not talk to each other directly. So, also known as the Closs fabric, I believe Charles Closs, CLOS, was the inventor or the brainchild behind this design. But the idea here with the 3-tier, or with the VXLAN type of design, is that you are no further than 2 hops away from anywhere you want to go. Typically, people are going to say 1, and I agree with that, because the spine isn't technically a hop. It's just it's a point in the network that you have to travel through. So what this is typically for the data center, right? Because you have a lot of high-speed east to west communication that you need to be able to provide and things like that. So where this one comes into play is you have a lot of east-west communication, whether it's servers to databases or storage, whatever it is that needs to be able to talk back and forth between the virtual machines or the servers or whatever it is that's communicating. You need high-speed connectivity in between them. So you're going to have, more than likely, 100 gig connectivity from your spines to your leaves. What's cool about this is this design is great for equal cost multipath, because if the more spines that you put in your data path between you and the remote leaf you're trying to talk to, That's just another flow that you can add in for communication. So ECMP is really, really good. So if you've got 100 gig, you theoretically have, in this case here, 4 100 gig pathways to get from this leaf to this leaf. And it makes your job, theoretically, a little bit simpler when it comes to scaling things out. So, but this Anycast gateway, you didn't notice that over here, right? Well, and I'm not going to get too much into terminology when it comes to first hop redundancy, like HSRP, VRRP versus Anycast gateway, which it basically just floats across the entire, all of your leaf switches. What I will talk about is when you start getting into these type of designs, this is mainly a data center type of design where you're going to have traffic coming into and out of the data center. And for example, this would be kind of a good example of how that comes into play. You got your connectivity and your spines. They go down to your WAN core. So traffic is going to come into your VXLAN fabric and then into your VXLAN fabric here. Talk to the servers doing whatever it is that they're doing, and then back out again. And this will work the same thing for the WAN. If you're going out to the internet or bringing traffic in from the internet or from the WAN edge through your firewalls, maybe your F5 load balancers, things like that, they can hit the fabric, that you have a high-speed fabric built out, and everybody's happy. As a matter of fact, I have replaced dozens of a 3-tier architecture with a spine leaf design because it made more sense to go that way because of what the customer needed. That we didn't do any VXLAN at all, but what we did is we gave them ECMP via the way that this architecture is put together. Now, is this architecture good for everything? No, it's really only specific to the data center. 3-tier and 2-tier architectures are good for what? Well, 3-tier are going to be for large sites, and 2-tier is going to be good for your medium and small sites because you just don't have the user base or the need to have that level of connectivity in place. So what's another architecture we talk about? Well, we talked about spine leaf architecture, but what about, and I'm thinking here what the other ones are. So you've got your 3-tier architecture, you got your spine leaf. What about your service provider? Even though most of you guys aren't here for service provider, what about your ring topology? Right? What about your ring? So we talk about ring. Let's take a look at what that does. What is ring topologies good for? Well, think about it from a service provider's perspective. You have a large geographic area, and you want to be able to get connectivity from point A to point B. Well, you trench fiber in a geographic area. Let's say you've got a 50 mile by 50 mile area, and you need to get all of these locations connected to each other via fiber. Well, you're going to trench fiber into the ground, right? That's going to be a cost to the provider, but the cost is okay because you're going to have potentially tens of thousands, if not millions, of people connecting into your fiber ring, and you're going to be able to provide them with internet or whatever type of service that you're potentially going to provide them. So when you take a look at it from this perspective, a lot of service providers, you're going to hear this, especially when you talk to ISPs, is we have a fiber ring in this area, we're going to plug you into that, and then we'll be able to get you out on the internet. There's fiber rings all over the country, and I'm US based, so there are fiber rings in a lot of different places. Now, are they the only type of topology you're going to see? No. However, in service provider networks, this is a very common design, especially on the edge, because it covers a very wide area, and you can have customers plug in here, 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 and then, typically the fiber rings are going to connect to some sort of head-end device like a hub router or what have you in a provider-operated location, and then you're gonna, and typically on a ring, your latency is pretty is pretty low. 5, 10 milliseconds, depending on what's going on, depending on which way in the ring you take to get from point A to point B. So the idea is to try to keep latency as low as you can. It's probably even faster than that now that I'm thinking about it. But the key thing is the faster the higher the speed of the ring, the more capacity it's going to have to give to the users that are attaching to it. And then you connect the rings together. And so before you know it, you have a Cisco, or I won't even say I'll say the internet topology. So what ends up happening is that, no, internet topology diagram, there we go. So you're gonna, okay, this is probably gonna be a bust. Let me see if I can say ring internet topology. I don't know if anybody's put something like this together. No, they have not. Okay, so essentially what I would want to kind of put into a visual for you is that if you were to take a map of the US and you were to take these topologies and put them together, what you're going to end up getting is you're going to get rings in all these different cities. So the rings are geographically local to your area, and depending on where you might live, they're all over the place. So let's say between Milwaukee and Chicago, let's say there's 10 rings, and those rings are connected to each other, and those hubs, so think of the ring as your access, and then the interconnectivity between them is going to be like your access to your distribution. And they're all going to backhaul to a certain part of the network. So your rings are your access layer switches, and you're going to have backhaul feeds into the core. Now, it could be aggregation. Actually, let me look at seamless MPLS. Okay, this is going to be a little easier to understand. Yeah, we'll do it this way. So I don't know if that's going to. Okay, this is Juniper segment routing, seamless segment routing MPLS. So with this topology here, what it's basically doing is you have these metro connections, right? And you have these branch offices, cell router. What ends up happening is you have your connecting right here, and then you have your provider edge, and these are built out all over the country, right? So it's how the service providers are going to connect you together. There's actually a really good topology that I don't know. So I know which topology I want to show you guys, but it's not popping up for me when I Google. Apparently my Googling isn't googly enough. All right, well, anyway. But the bottom line here is you got these rings. What would the difference between a aggregation and core? Great question. So your aggregation is going to be all of your connections that are taking your ring connectivity is going to connect to your aggregation. So you're going to have a bunch of circuits coming in to your aggregation switch or aggregation device. It could be a router with lots of line cards in it. And then that's going to be aggregating a bunch of different services. Think residential cable or residential DSL, right? You're going to have whether it's a cable modem termination system, a CMTS, or you're going to have a DSLAM. They're going to be taking a bunch of connections in from your customer base in a particular area. That's going to be an aggregation. It's going to be collecting them all together. And then it is going to hand that traffic off to a core device. So you're going to go from, say, and your bandwidth speeds are going to jump up when you talk about this. You're going to have, let's say the average speed for your cable is like 500 megabit, right? Well, you're going to go from 500 megabit up to gigabit. Probably more like 100 gig into your from your ag into your core, and in the core you're going to have 400 gig, if not bigger. And typically speaking, you're going to have bigger pipes than that. You're going to be leveraging things like DWDM. You're going to be leveraging things dense fiber and multiple paths for it, up to and include, if not beyond, terabit connectivity between all these sites. Because what you're doing at that point is all you're, I don't want to say you're throwing bandwidth at the problem, but when you're aggregating, you're trying to get as many individual connections together at the same point, pump them into a bigger pipe, and then from there you're distributing it through the core. And the key thing when you're talking about service provider architecture is you want to do this as quickly as you can. You don't want to inject any additional latency into the network flow than you have to. So the fewer amount of devices that you have to pass your traffic through, the better. Because as I'm sure you know, if you add devices in the data path for the sake of adding devices in the data path, you're adding unnecessary latency, because every time you pass through another network device, you have to do a packet lookup, right? You have to figure out where to send it. If you can minimize the amount of lookups that are done, you're going to increase the latency, or you're going to decrease the latency. But that it's going to kind of be a trade-off too when you think about it, because the further away you get from point A to point B, let's say you're in LA and you're trying to talk to New York, let's say that's a 60 millisecond across the US time frame. Well, if I have to go through 40 routers to get there, but if I was to take that 40 routers back to 35 and take a different path, maybe my latency drops down to 55 milliseconds. So you have to take into consideration stuff like that too. So there's the speed at which you're connecting, and then you also have your end-to-end piece that comes into play with what is the end user experience going to be like. And it really comes down to application experience. Are people going to complain if the spinny circle goes? As a matter of fact, I hope that answers your question. First of all, if it's not, if you have a specific on that, I'm happy to dive into it a little bit further. But I remember watching this series on Netflix about Netflix, and I'm sorry, no, Spotify, and how when they were trying to figure out the algorithms and things like that, the human ear takes 200 milliseconds to detect audio. Well, if whoever the guy, I can't remember the guy's name, but whoever was running the show there, he wanted to have it so fast that it was instantaneous. He didn't want to wait for buffering or a download. He wanted to go right away. And those are the things that come into play when you're talking about the speed of connectivity, right? So when you pull up your phone, or in my case, I have the Spotify app on my computer. If I want to go listen to Spotify or I want to listen to YouTube, it's just about instantaneous. Now, if you're, depending on where you're at, in a lot of the reasons why real-time applications appear to be real-time is because a lot of distributed connectivity. You have content distribution networks, or CDNs, spread all across the world now with the way that the internet is built. And those are things that come into play where when you talk about connectivity, that's what makes those things possible. Now, you rewind the clock 20 years back in the day when if you wanted to go download a song, you were waiting, 10, 15 minutes on your 128-bit or 128 kilobit ISDN connection. So yeah, I see. This is like in big networks. You want to get the traffic off your network as quick as possible. No, you're good, man. I was just, it's that can be taken a bunch of different ways. If you're talking, like service provider level stuff, you're absolutely right. Which is what they refer to as hot potato routing. You want to get the traffic from point A to point B as quickly as you can. You don't want to route it through your backbone just because you've got the ability to do so. However, if you're talking stuff like this, where you've got aggregation in core or distribution in core, why would it make more sense to have a 2-tier architecture versus a 3-tier architecture? And to be honest with you, a lot of the times it comes down to cost. Customers don't want to spend extra money for extra hardware if there's really no benefit or justifiable reason to have it there. If you have, at least in my experience, you're going to have a couple of different architectures that you're going to work with when you're working on customer networks, right? You're going to have your a validated design for your big location, and then you're going to have another validated design that's for a medium-sized location, and then another one for your small location. And then depending on the scenarios at hand, you may or may not deviate that from that depending on the geographic area. Maybe cellular service in a particular part of the country is just really bad. And so it doesn't make sense to bring in cellular backup. Maybe it makes more sense to have satellite backup. Maybe you go out and get Starlink, or you spend a little bit extra to bring in a really, really slow DSL circuit because it's better than cellular, or whatever the case might be. So you're going to typically have validated designs that you're going to use for deployment so that you're not having to guess your way through what's going on. You're just going to be able to, a new site comes into play, you go to your reference architecture, you've already got, you might have to go out for pricing because, prices change on hardware as time goes on. You go out, you grab the details that you need to, you go to whoever your vendors are, you get a quote for said hardware, and then you're like, okay, it's going to cost me X amount of dollars. So, and then that becomes kind of your standard. And there's really no guesswork in it because you've already done the heavy lifting already to figure these things out. And that's why, in my opinion, if you're going to do architecture, whether it's for a customer or you're going to be working at a Cisco partner or you're working for one of the big ISPs or whatever the case might be, you're going to want to understand the architectures that they're working with. And that's a big deal because especially when you start getting into the conversations of connectivity and then requirements for different applications and things like that, the higher up in the OSI model you go with your conversations, the less and less people care about what it actually looks like from a connectivity perspective. Because at the end of the day, if you put yourself in the user's shoes, and you've got a user that they're on their computer at their office and they click on a button on their desktop in order to launch some sort of application, that they're doing on a regular basis, they're expecting a certain amount of time between them double clicking, getting a prompt to log in, and then being able to access whatever it is they're trying to do. So if that time frame goes up dramatically and it stays there over a period of time, they're going to complain. When they complain, that trickles back down. So you leave layer 7 of the OSI model, the presentation layer, and then you're down in layers 2, 3, and 4. Okay, why is it taking so long? Maybe it's a layer 1 problem. Maybe you've got a lot of packet loss for some reason. Maybe a backhoe took out a fiber. Fiber's allergic to backhoes. It's an ISP joke, since considering I work for a service provider now. So in those particular cases, at the end of the day, you and I really only pay attention to layers 2 and 3, right? We only care about MAC addresses and IPs. Every once in a while, we'll go up into layer 4 to talk about TCP and UDP and port numbers and things like that if specific things aren't working. But typically, once we're done with that, we drop back down to layer 2, layer 3. That's where we live, right? That's where network guys we hang out. We only go to layer 7 when a computer or when a user complains about their application experience. We drop down to layer 1 when what? Circuits go down, right? But normally we stay layer 2 and layer 3. That's what we know. So in those particular cases, knowing, if you've got a scenario where, somebody comes to you and says, hey man, I'm going to put you in charge of deploying this new site. Okay, cool. How many, you might, obviously there's going to be more to it than that initial conversation, but you're going to know shortly thereafter, you might even initially know which particular design you're going to throw at it because you've done your due diligence to figure these things out. But let's say, for example, they don't tell you right away and you start digging into it, you get pulled into the meetings, and then before you know it, you're like, oh, okay, yeah, I've got this. And you know that you need to go reach out to Cisco and Aruba and Palo Alto because you're doing Palo on the edge for your internet and your private WAN. You're doing Cisco access points, and then you're doing Aruba switches, for example. That's a customer that I used to work with. So it's a mixed match of things, and you go out, you get your quotes for the hardware, and to get an idea of when the time frame is going to be for this hardware to come in. Let's say it's a 90-day lead time. So you've got basically 90 days to figure out your addressing scheme, which is probably already going to be there. So to do all your architectural work. I've talked about this before too, your 80-20 rule. You're going to spend 80% of your time to do 20% of the actual work that matters. So it all matters, right? It all adds up to 100, but you're going to spend your time addressing and understanding all the details around those things, getting all those stuff into play. So by the time the hardware gets there, all you're doing is getting it powered on, you're making sure the right version of code is on it, and then you're configuring it. And if you're like in my shoes, excuse me, then once everything's done, configured, everything's good to go, you box it back up and you ship it out to where it's got to go. So it's almost plug and play. And if you're doing your job correctly, you really shouldn't have to do any lifting of anything per se once it comes time to deploy. You know, you might be in charge of going on site to do the deployment, but oftentimes you're not, right? At least in my experience, I was able to do most of my job remotely, as long as there was people locally to that area that would go there. They'd have to plug it all in. And my job, for probably well over 100 projects over the course of about a year and change, the only thing that I was responsible for doing is making sure things came up the way they were supposed to. You know, I'd be logging into SolarWinds and making sure that I could log into this piece of gear, that piece of gear, and things were coming online. Stuff like that. Because I had already done the heavy lifting, all the configuration was done, put on the devices, all that type of stuff. So it was literally just rack it in, put it in the rack, cable it all up, power it on, and then magically things come to life. Talking about collapsed core design, I have failed to argue against stacking stackwise virtual VSS cores, but I still see it a lot. Client architects don't see the shared control plane as a risk. Interesting. Okay. So let me ask you this: why do you see it as a risk? That's actually a really good, really good talking point, because I would be the first one to recommend going that way, because chassis aggregation, you can stack it together, you can do port channels, things like that, which you normally can't. Am I getting too concerned for something Cisco seems to sell as a feature? I wouldn't say concern. I mean, if you to me, it's one of those things where, what's your major hiccup or what's your hang up? Like, if you're, and I'm not calling you out, but since you put it out there, it's like, okay, well, I've got time. I don't have a dead drop at 8 o'clock. If you want to like chat it out, I'm fine with you chatting it out. But in my opinion, the first thing that I go to, and for those of you that are watching this that don't know what he's talking about, is the Cisco Stackwise. So what he's talking about, or Stackwise Virtual, what he's talking about is taking the cables, this is more of the power, but you're taking multiple individual pieces of equipment, and instead of having four separate switches, for example, like what I'm mousing over right now, you connect them together with a cable, a Stackwise cable, so the four switches appear like one. Instead of you going out and getting like a 6509 or a 4506 or whatever bigger piece of hardware you have, you're able to use the cabling to extend the back plane and the control plane between them. So what he was referencing here as the shared control plane is, if I SSH into the switch, the master switch is going to respond to that. And if I run any commands, if I do like a show interface status, I'm going to see four switches. So it's going to be like gig 1 through 48, then gig 2 1/48, so on and so on. So each number increments for the amount of members you have in the stack. So in my opinion, when you have this type of stuff set up, this is the direction. This is the type of stuff that you need to be familiar with. So we're going to I'm not at all surprised you see what you're saying. Not at all, man. There's no derailment or sidetrack at all. I mean, we're talking about architecture, and this is part of that. It doesn't have to be whiteboard and a 3-tier versus 2-tier and things like that. If you want to talk about why you would go with a particular solution, I'm happy to chat about it. It's just the world I live in. So when you start talking about connecting, you get your 4 switches in your stack, and then you got a switch down south of it. Instead of you having a triangle, it doesn't look like a triangle, right? It looks, you have those links going up, and you port channel it together, so you aggregate. So it's supposed to make things simpler, is the intention, but that's not always the case. So I have had to deploy quite a few. The 9500 takes up ports. Yeah, that's. Whoops. Wait. Wow. What? Holy cow! Restart now. It was started at 8:11. Oh wow. I guess I am stopping the live stream soon. I did not see that coming. All right. I worry about the bugs we get affecting both chassis or fat fingering command and dropping both switches, more just a risk mitigation. Yeah, I completely agree with you on that. There are bugs that can affect the entire stack, or you fat fingering and taking switches offline. Completely agree with you. Those are scenarios where it's, I guess my argument or rebuttal to that would be, I don't like to use the term argument. My rebuttal or my response to that would be, that's going to be more of a corner case type of scenario. So if obviously we can't see bugs until they come out or until we hit one. But so in those situations, maybe it makes more sense to, well, actually, you know what, to be honest with you, I don't really know. I really wouldn't. I would say your fear is justifiable, 100%. Like if I was sitting across from you in a conference room, I'd be like, justifiable fear. But on a scale of 1 to 10, where do we feel like that is going to be a legitimate concern? You know what I mean? And then you have to, because that's where you have to start weighing out your options, is what you're suggesting with going with a chassis versus doing individual switches in a stack. Is one way better than the other? They both get the same job done, as far as I'm concerned. And that's when you really had to dig into the details of which one makes more sense. So now, the one thing that I would toss across, back to the table across, would be, okay, so let's say we go with chassis-based switches. That's fine. Well, what happens if the line card goes down and the back plane of the chassis is just, you go RMA, you get a new line card, the line card goes into the chassis but doesn't boot. So those are some things that I would be like, in that case, I would just pull the switch out of the stack, and then I would put a new switch in the stack in its place. It's going to rebuild itself. So I would, that's probably the direction I would go with your perspective. Not that your perspective is wrong. It's totally, definitely a valid one. Is core stacking necessary in SDA? I honestly have no idea. I don't have very much experience with SDA at all. It's one of those things where I would like to learn it eventually. I'm actually patiently waiting for Cisco to release CML 2.7 to see if the, what do you call it? The Cat 9K is fully supported. Stackwise Virtual offers ISSU in-service software upgrade, so it's easier to upgrade if you hit a bug. That is a good point. You'd upgrade like your standby, then upgrade and then flip over the primary to backup, and then upgrade what was the primary that's now backup. You'd upgrade that, so the box typically stays online all the time. So I agree with you on that one too. So are there ways of getting around your fear? Yes. Doesn't always support, so downtime sometimes it is, and that's so in that particular case, and that's a valid argument as well. What I would say to that is, if there's a bug and you've hit a bug, that needs to be, open up a TAC case, get a TAC engineer to give you some documentation, and go through the TAC process, and then from there, then you can take that to management and be like, okay, this is what we got to do. There's it is what it is. They can't hold you responsible for it because it's not software that you wrote or hardware you built. So Is it maybe a platform you suggested and you went for and you advocated for? Maybe, but you can't see into the future. Neither can I. So I think they're. I don't think one way is worse or better than the other. They both have their caveats, and you have to deal with them as they come. And I think that's really what it boils down to. But yeah, it's good stuff, man. It's one of those things where you deal with the problems as they come, and I try not to worry about the things that I can't control, and be like, hey, you know what? This is what Cisco said. This is what TAC came back with. It is what it is. There's nothing I can do. You kind of wipe your hands of it and keep moving forward. So, but I got a couple more minutes before my computer is going to reboot itself. So, if you guys have any other things you'd like to chat about, feel free to do so. And if not, we can take this. We could always take this conversation we're talking about now. We can dive into that more in depth in the next Whiteboard Wednesday. But I think that would be kind of a cool topic to dive into. Would be stacking. I can look into do a little bit of research on SDA, see what the options are. Maybe talk a little bit more about that. I'll spend a little bit of time learning SDA beyond the basics that I know about it and things like that. So hopefully maybe that'll work out. Exactly. No right answer, but what the client and architects agree on. Exactly. Should be soon and see what's live. He yesterday gave hope on a close release date. Okay, cool. Yeah, I'm looking forward to seeing CML 2.7 get released, and I don't want to say I have fingers crossed that the Cat 9K is fully baked like Nexus 9K is, and it supports everything that I want to do. Because part of me would like to play around with SDA and see if I can't get it working in a virtual environment. But because I can get access to DNA Center and see about putting that together. But I would want to completely play with it first before I would even begin to start messing around and showing you guys anything on YouTube. But so anyway, that is pretty much where we're going to end here. I'm going to be forced to cut the stream. I mean, we're already over the hour mark, which is what I had scheduled for. So next week, no, you gave me a great idea. I'm going to go ahead and dive into stacking. We can take the architecture discussion a step further. We'll talk about stacking and the different ways that you can stack, and then dive into SDA a little bit and how it correlates with that, and start diving into those details. And hopefully that'll put you guys on the right track where your studies are going and things like that. So I have a game plan. So normally I don't have a game plan, but thanks for throwing something out there. We'll put that on the calendar for Wednesday next week. All right, guys. Well, my time to reboot is quickly approaching, so I'm going to go ahead and let you guys go. Do you go into ACI now? I can. I don't have a ACI environment to play with, but what I could do is I know a guy that does ACI, so I can try to reach out to him and see if he'd be willing to come on and talk. I know Omar personally, so maybe I can make that happen, but I can definitely talk about ACI at a high level. I don't know like the intricacies of it, but that'd be kind of cool to dive into. But we'll see if I can't figure out something with that. But yeah, this video will be available for review here shortly, and then